So I was drinking tea again in the evening, and I thought, what if the cup was semicircular as many of my teacups tend to be? So I thought, okay, since I have free time on my hands, and clearly project work is way too difficult to do, why don't I just calculate the height that is required to fill half a teacup, which is semi-spherical. So we know that the volume of the cup is elementary. It's taught in any high school that it's 2 by 3 pi r cube because it's half of a sphere. So the volume of a liquid is a bit more interesting, I think. So we have a right triangle here like this, and the hypotenuse of this right triangle is capital R. So this would be small r squared plus capital R minus h whole squared equal to r squared. So this would be r squared plus h squared is equal to 2h capital R. So r squared ends up being, what does r squared end up being? It ends up being 2hr minus h squared. So the volume of this liquid would be equal to just a surface of, it's basically a volume of revolution, right? So it's pi integral 0 to h of r squared dh is equal to pi integral of r squared. So we just have to integrate from 0 to h to hr minus h squared dh. So this is an easy integral. This is just pi h squared by 2 h squared r minus h cubed by 3. Which is just pi h squared by 3 into r minus h. Sorry, this is also multiplied by 3. 3r minus h. So we can just take the ratio now. So wait, yeah. So pi by 3 get ignored. So V liquid by V cup. V cup is equal to, what is it equal to? I don't know. Pi by 3 we can ignore. So it would be 2r cube at the bottom. At the top it would be h squared into 3r minus h. And this we want to be half. Well, that's the goal, to fill half cup. So this 2 and this 2 cancel out. So it's r cube is equal to 3h squared r minus h cubed. So we can divide everything by r cubed and we get h by r whole cubed minus 3h square by r square. Okay, so 3 by h by r whole squared plus 1 equals to 0. And let's assume h by r is some ratio y. So it's y cube minus 3y square plus 1 equals to 0. So this seems to be a cubic equation that I need to solve. So let me just think about how to solve this and I'll be back. Okay, so it turns out that a cubic equation is not that simple to solve. This particular one is kind of simple to solve because we can do some substitutions to make this kind of y squared term become a simple y, like a linear term, and then we can do another substitution to make this entire thing quadratic equation, and we can make some assumptions that are standard for cubic equations. But solving cubic equations is kind of really not my forte, and I don't know if I would be able to explain or even do it myself. So I'm just going to plug it into Wolfram Alpha or even Mathematica works, but I use Wolfram Alpha. So that will give me the values for y. So the values for y that come out from this, it's a cubic equation, so there are three values: 0.53, 0.65, and the last value is 2.88, and this is equal to h by r, obviously, which is our required ratio. So obviously our ratio cannot be a negative number and it cannot be greater than 1. So we deduce that h by r is equal to 0.65 when half the volume is filled. So we need a height of 0.65, the entire height of the cup, which is actually similar to the frustum volume of height required, which is around 0.648, I think. So yeah, see, it turns out that you can eyeball about 0.65 of the height, and that should give you the required volume for any kind of standard non-cylindrical cup. So yeah, I haven't double checked this maths. I mostly performed it on the fly, like alongside you guys. So yeah, I mean, it's up to you to trust me, or you can try doing it yourself. I don't know. Seems right to me, but yeah. So this is the conclusion.